Okay, this is Mr. Coumbe. Let's do another gas stoichiometry problem. Pause this video so that you can read the question and then let's answer it. Okay, so in this one, once again, you're going to need a reaction. So let's have a look at the reaction. We have liquid carbon disulfide, so CS2, and that's a liquid. And we combust that, okay? We combust that with an oxygen gas, and it produces carbon dioxide gas and sulfur dioxide gas. So now let's balance this equation. So on the left hand side there are two sulfurs, so this needs to be doubled here. So now, and on the left hand side we have one carbon dioxide, so it's almost balanced. So here we have two oxygens here and one here, so it needs to be 3 here. So let's do the molar ratios. So for every 1 carbon disulfide, we need 3 oxygens. You produce 1 carbon dioxide and 2 sulfur dioxide. So here, notice that not all the components in this reaction are gases. We have a liquid here. So here, the volume for carbon disulfide is not going to be as predictable as it will to gases, because all gases will occupy 22.71 liters for every mole, and that's for gases. Now this liquid of carbon disulfide, that won't necessarily occupy that amount of volume. It'll actually occupy much less volume because the liquid particles are much closer together than gas particles are. So, however, we don't even need to know about carbon disulfide because it tells us how much oxygen we have. So if we know how much oxygen we have, so we have the volumes. So volumes, we don't know that. So this one, we don't need to know carbon disulfide. We do know how much oxygen we have. So we have 450 mils of oxygen. Our ratios, our volume ratios will still stay constant according to our molar ratio with our gases. So if I have if you compare 3 to 1, and if we do it the long way, you can even do this in your head, but if you do it the long way, the volume of carbon dioxide gas is going to be 1/3 of the volume of our oxygen, which is essentially 150 mils. And same on the right hand side, our volume of our sulfur dioxide is going to be 2/3 of the volume of our oxygen, which is I think 300 mils off the top of my head. Okay, here we go, it is solved.